The fluid shifts investigation is designed to determine what is causing this microgravity ocular syndrome. This changes in astronauts' vision and ocular structure that some people are calling the visual impairment and intracranial pressure syndrome. We think that what's causing this problem is the headward fluid shift experienced in spaceflight. When there's no more gravity pulling the blood to your feet, all of the blood and other fluids in your body circulate in your upper body, around your heart, your neck, and your head. And the purpose of this investigation is to determine if these headward fluid shifts are in fact related to changes in brain pressure and eye structure and vision. This is a collaborative study using international partners. I believe it's one of the largest ever to fly on the International Space Station. We have some Russian Space Agency co-investigators on our experiment. And they have a device in the Zvezda Russian service module called the Chibis, which is a lower body negative pressure device, which we think would be an effective countermeasure to these headward fluid shifts experienced in spaceflight. So this is complex in that the Chibis device is anchored to the Russian portion of the space station because they have medical monitoring hardware that can't move. So in order for us to take all of our measures while undergoing lower body negative pressure, we have to transport all of our hardware from one end of the station to the other. So this involves multiple crew members. It takes several hours to transfer the hardware and to stow it before we use it. And then during the actual investigation, it requires 3 crew members. One of them will be a Russian, either a test subject or an operator or a medical monitor to monitor the test subject's vitals during the experiment. This will indirectly benefit folks that suffer from intracranial hypertension or elevated pressure in their brain that would normally require something like a lumbar puncture, an invasive lumbar puncture, to determine what the pressure is. We're investigating many non-invasive modalities for measuring that intracranial pressure, and if it turns out that these hardware are effective in doing this, we may save some invasive procedures for clinical populations here on Earth. I absolutely think this is a stepping stone towards future missions. I think if we want to stay in space for longer than 6 months and to explore, we have to solve this visual impairment syndrome.